Hello. Welcome to the online lesson on the Geography of Turkey 1, Physical Geography of Turkey course. In today's session, we will delve into the soil classification and main soil groups of Turkey. Turkey exhibits a diverse range of soils due to variations in climate, topography, and geology. The main types of soil in Turkey can be categorized as follows. 1. Gray-brown soils, Grisoils. These soils are common in the Marmara, Aegean, and Mediterranean regions. They are characterized by a light gray to brown color and are often fertile. 2. Red-brown soils, Luvisols, found in various regions, including the Central Anatolia and Eastern Anatolia. These soils have a reddish-brown color and are moderately fertile. 3. Chestnut soils, Cambisols, located in regions such as the Black Sea and parts of Eastern Anatolia. These soils are brown and well-drained, suitable for agriculture. 4. Sandy soils, Arenosols, predominantly in the Central Anatolia region. These soils are sandy and less fertile, posing challenges for agriculture. 5. Saline soils, Soloncax, common in arid regions like the southeastern part of Turkey. These soils have high salt content, limiting their agricultural suitability. 6. Alluvial soils, found along riverbanks and deltas. These soils are nutrient-rich and well-suited for agriculture. Examples include Sukurova's alluvial plains. 7. Volcanic soils, areas with volcanic activity, such as parts of Central and Eastern Anatolia, may have soils rich in volcanic ash, providing fertility for crops. 8. Forest soils, these are found in regions with significant forest cover, such as the Black Sea region. They support forest ecosystems and are characterized by organic material accumulation. 9. Steppe soils, predominant in steppe and semi-arid regions. These soils are often sandy and less fertile, influencing the vegetation types in these areas. It's important to note that within these broad categories, there can be further subdivisions based on specific characteristics and local variations. The diversity of soils in Turkey contributes to the country's varied ecosystems and agricultural practices. The soil types in Turkey based on the zonal, intrazonal, and azonal classification. Zonal soils. 1. Brown forest soil, common in forested regions, characterized by a well-developed organic horizon. 2. Terra rossa soil, found in the Mediterranean region, known for its red color and rich fertility. 3. Brown steppe soil, predominant in steppe areas, often sandy and less fertile. 4. Chestnut steppe soil, typical of steppe regions, characterized by a chestnut color and moderate fertility. 5. Chernozem soil, found in grassland regions, known for its dark color and high fertility. Intrazonal soils. 1. Vertisol, soils with a high content of swelling clay, found in various regions and prone to cracking and swelling. 2. Renzina, common in limestone areas, characterized by a dark, fertile surface layer. 3. Salty soil, soils with elevated salt content, often found in arid and semi-arid regions. Azonal soils. 1. Alluvial soil, deposited by rivers and streams, typically fertile and suitable for agriculture. 2. Colluvial soil, accumulated at the base of slopes due to gravity, influenced by the material from higher elevations. 3. Regisol, soils with limited horizon development, often found in areas with recent geological processes. This classification provides an overview of the major soil types in Turkey, considering their regional distribution and specific characteristics. The 5 main latitude regions of Earth's surface comprise geographical zones, divided by the major circles of latitude. The differences between them relate to climate. They are as follows. The North Frigid Zone, between the North Pole at 90 degrees north and the Arctic Circle at 66 degrees 3348.7 N, covers 4.12% of Earth's surface. The North Temperate Zone, between the Arctic Circle at 66 degrees 3348.7 N and the Tropic of Cancer at 23 degrees 26 minutes and 11.3 seconds north, covers 25.99% of Earth's surface. The Torrid Zone, between the Tropic of Cancer at 23 degrees 26 minutes and 11.3 seconds north and the Tropic of Capricorn at 23 degrees 26 minutes and 11.3 seconds south, covers 39.78% of Earth's surface. The South Temperate Zone, between the Tropic of Capricorn at 23 degrees 26 minutes and 11.3 seconds south and the Antarctic Circle at 66 degrees 33 minutes and 48.7 seconds south, covers 25.99% of Earth's surface. The South Frigid Zone, from the Antarctic Circle at 66 degrees 33 minutes and 48.7 seconds south and the South Pole at 90 degrees south, Covers 4.12% of Earth's surface. Earth's climatic zones: ice cap, tundra, boreal, warm temperate, subtropical, tropical. On the basis of latitudinal extent, the globe is divided into 3 broad heat zones. Certainly. Here's more detailed information about the zonal soils in Turkey. 1. Brown forest soil. Characteristics: found in forested regions, this soil type has a well-developed organic horizon, horizon. It is generally fertile and supports diverse vegetation. Distribution: common in areas with significant forest cover, such as the northern regions of Turkey. 2. Terrarosa soil. Characteristics: this soil type is characterized by its red color, indicating the presence of iron oxides. It is fertile and well suited for agriculture. Distribution: predominant in the Mediterranean region, where the climate influences soil formation. 3. Brown steppe soil. Characteristics: typically sandy and less fertile, brown steppe soil is found in steppe regions and is associated with drier conditions. Distribution: common in steppe areas across the country. 4. Chestnut steppe soil. Characteristics: this soil type has a chestnut color and moderate fertility. It is associated with steppe regions but may have slightly better fertility compared to brown steppe soil. Distribution: found in steppe areas, often in transition zones between forested and drier regions. 5. Chernozyom soil. Characteristics: Chernozyom is known for its dark color and high fertility. It is one of the most fertile soil types and supports grassland vegetation. Distribution: common in grassland regions, particularly in the central and eastern parts of the country. These zonal soils play a crucial role in shaping the landscape and influencing agricultural practices in their respective regions of Turkey. Brown forest soils. 1. Characteristics. Horizons: brown forest soils have distinct soil horizons, including the O horizon, organic horizon, rich in organic matter, the A horizon, topsoil, with mineral material mixed with organic material, and the B horizon, subsoil, with accumulated minerals. Color: the color of the A horizon is typically dark brown, reflecting the high content of organic material. Fertility: these soils are generally fertile due to the presence of organic matter, supporting the growth of various vegetation types. 2. Formation. Brown forest soils form in forested regions where the decomposition of plant material contributes to the organic horizon. The leaching of minerals from the upper horizons accumulates in the lower horizons. 3. Distribution. Commonly found in the northern regions of Turkey, where there is significant forest cover. Regions with deciduous and coniferous forests contribute to the formation of brown forest soils. 4. Land use. These soils are suitable for agriculture, supporting the growth of crops and forest vegetation. They are used for various agricultural activities, including the cultivation of crops and forestry. 5. Challenges. Erosion can be a concern in areas with steeper slopes and improper land management practices. Human activities, such as deforestation or improper agricultural practices, can impact the health of brown forest soils. Understanding the characteristics and distribution of brown forest soils is essential for sustainable land use and agriculture in the regions where they are prevalent. Acid and lime-free forest soils. 1. Characteristics. Acidity: these forest soils are characterized by their acidic nature, with a low pH level. The acidity is a result of organic material decomposition, leading to the release of acids. Lack of lime: lime-free refers to the absence of calcium carbonate, lime, in significant amounts. Lime can act as a buffer against soil acidity. 2. Formation. High washing areas: acid and lime-free forest soils are formed in regions where there is high rainfall or significant leaching, resulting in the removal of basic ions like calcium. Decomposition process: the acidic nature is often a consequence of the decomposition of organic material, contributing to the accumulation of organic acids. 3. Distribution. Regions with high rainfall: these soils are commonly found in areas with high precipitation, where leaching is prevalent. Forest ecosystems: acidic forest soils are associated with regions dominated by forests, where organic material from vegetation contributes to soil formation. 4. Land use. Challenges for agriculture: the acidity of these soils can pose challenges for certain crops that prefer neutral to slightly acidic conditions. Forest ecosystem support. Acid and lime-free forest soils are well suited for supporting the growth of forest ecosystems. 5. Importance. Biodiversity. These soils play a role in supporting biodiversity in forested areas, providing specific conditions for certain plant species. Environmental impact. Understanding the characteristics of acid and lime-free forest soils is crucial for managing and preserving ecosystems in regions where they are prevalent. The knowledge of soil characteristics helps in making informed decisions regarding land use, agriculture, and conservation practices in specific regions. Brown forest soils in the North Anatolian Mountains, Turkey. 1. Geographical location. North Anatolian Mountains. Brown forest soils are commonly found on the slopes of the North Anatolian Mountains in Turkey. Facing the sea, the specific distribution mentioned suggests that these soils are prevalent on the slopes facing the sea, indicating a connection between soil formation and the coastal environment. 2. Climatic influence. Moderate to high rainfall. The presence of brown forest soils is likely influenced by the climatic conditions of the region. These soils thrive in areas with moderate to high rainfall. Leaching and soil formation. The proximity to the sea and the associated climatic conditions contribute to leaching, which is a key factor in the formation of these soils. 3. Soil composition. Acidic nature. Brown forest soils are known for their acidic nature, and this characteristic is likely present in the soils on the North Anatolian mountain slopes. Organic material. The decomposition of organic material, common in forested areas, contributes to the formation of these soils. 4. Ecosystem support. Forest vegetation. Brown forest soils are well suited for supporting forest ecosystems. The slopes of the North Anatolian Mountains facing the sea may be covered with vegetation adapted to these soil conditions. 5. Land use considerations. Agricultural challenges. The acidity of brown forest soils can present challenges for certain types of agriculture. Farming practices in these areas may need to consider soil amendments. 6. Conservation importance. Biodiversity hotspots. Areas with brown forest soils are often biodiversity hotspots, supporting a range of plant and microbial life. Conservation efforts may target these regions to protect unique ecosystems. Understanding the distribution of soil types in specific geographical regions helps inform land management practices, conservation strategies, and sustainable land use planning. Utilization of brown forest soils in Turkey. 1. Ideal conditions for agriculture. Tea and kiwi cultivation. The well-washed nature of brown forest soils makes them highly suitable for specific types of agriculture. Tea plantations. Turkey's regions with brown forest soils, especially those on the slopes of the North Anatolian Mountains facing the sea, provide ideal conditions for tea cultivation. Kiwi orchards. The acidic nature of these soils can be advantageous for growing kiwi, a fruit that often thrives in slightly acidic conditions. 2. Factors contributing to suitability. Drainage and moisture retention. The well-drained characteristic of these soils prevents waterlogging, while still retaining enough moisture for crops. Leaching and nutrient availability. Leaching in brown forest soils contributes to nutrient availability, promoting healthy plant growth. 3. Agricultural practices. Soil amendments. Farmers in these regions may use soil amendments to optimize pH levels and address any nutrient deficiencies. Crop rotation. Sustainable agricultural practices, including crop rotation, may be employed to maintain soil fertility. 4. Economic impact. Agricultural economy. The cultivation of tea and kiwi in regions with brown forest soils can contribute significantly to the local and national agricultural economy. Export opportunities. Both tea and kiwi are products with export potential, enhancing economic opportunities for farmers in these areas. 5. Challenges and considerations. Soil conservation. Intensive agriculture can lead to soil erosion. Implementing soil conservation measures becomes crucial to maintain the long-term productivity of brown forest soils. Sustainable practices. Encouraging sustainable agricultural practices ensures the continued suitability of these soils for cultivation. Understanding the specific crops that thrive in certain soil types allows farmers and policymakers to make informed decisions about land use, crop selection, and sustainable agricultural practices. Certainly. Here's an explanation. Utilization of red Mediterranean soils, terra rossa, in Turkey. 1. Vineyard cultivation. Grapes and wine production. terra rossa soils are well known for their suitability for vineyard cultivation. Grapes grown in these soils contribute to Turkey's vibrant wine production industry. Wine regions, regions with terra rossa soils, such as parts of the Mediterranean coast, are often associated with high-quality wine production. 2. Factors contributing to suitability. Mineral content. Terra rossa soils are characterized by their high mineral content, including beneficial minerals for grapevines. Drainage. Good drainage in these soils prevents waterlogging, which is essential for grapevines. 3. Agricultural practices. Terracing. In hilly or sloped areas with terra rossa soils, terracing may be employed to maximize land use for vineyards. Precision viticulture. Modern agricultural techniques, such as precision viticulture, may be used to optimize grape production and quality. 4. Economic impact. Wine industry. The cultivation of grapes in terra rossa soils contributes significantly to Turkey's wine industry. Tourism. Wine regions often attract tourism, providing economic benefits beyond agriculture. 5. Challenges and considerations. Soil erosion. Given the hilly terrain where terra rossa soils are often found, soil erosion can be a concern. Implementing erosion control measures is essential. Climate sensitivity. The suitability of terra rossa soils is closely tied to the Mediterranean climate. Climate change considerations may impact long-term suitability. 6. Sustainable practices. Organic farming. Some vineyards in terra rossa regions may adopt organic or sustainable farming practices to enhance soil health and preserve the ecosystem. Water management. Efficient water management practices are crucial, especially in regions prone to seasonal droughts. Understanding the specific characteristics of terra rossa soils and their impact on grape cultivation allows stakeholders in the wine industry to make informed decisions for sustainable and quality wine production. Utilization of terra rossa soils in Turkey. 1. Viticulture and wine production. Grapes. Terra rossa soils are known for their suitability for viticulture. Wine production. These soils contribute to the cultivation of grapes used in the production of wine, supporting Turkey's wine industry. 2. Olive orchards. Olive oil production. In regions with terra rossa soils, olive orchards may be established, contributing to the production of high-quality olive oil. 3. Fruit orchards. Citrus fruits. Terra rossa soils may support the cultivation of citrus fruits like oranges and lemons. Fruit production. These soils play a role in fruit orchards, supporting the production of various fruits. 4. Vegetable farming. Tomatoes, peppers, and eggplants. Terra rossa soils may be suitable for vegetable cultivation, contributing to the production of ingredients used in Turkish cuisine. 5. Herb cultivation. Mediterranean herbs. The unique characteristics of terra rossa soils may support the cultivation of herbs commonly used in Mediterranean cuisine. 6. Landscaping and gardening. Floral diversity. Terra rossa soils may be utilized in landscaping projects and gardening, contributing to the diversity of flora in certain regions. 7. Sustainable practices. Organic farming. Some farmers may adopt organic farming practices in terra rossa soils to enhance soil health and produce organic crops. Water management. Efficient water management practices are crucial, especially in regions prone to seasonal droughts. 8. Biodiversity support. Ecological value. Terra rossa soils may contribute to the overall biodiversity of the regions where they are found, supporting a variety of plant species. Understanding the agricultural and horticultural potential of terra rossa soils allows farmers and land managers to make informed decisions about crop selection, sustainable farming practices, and the promotion of biodiversity in these regions. Utilization of brown steppe soils in Turkey. 1. Grain crops cultivation. Wheat and barley. Brown steppe soils are often suitable for the cultivation of wheat and barley, contributing to the production of staple grains in Turkey. 2. Pulse crops. Lentils, chickpeas, and peas. These soils may support the growth of pulse crops, enhancing the diversity of legumes in Turkish agriculture. 3. Oilseed crops. Sunflower and soybeans. Brown steppe soils may be utilized for the cultivation of oilseed crops, contributing to the production of vegetable oils. 4. Forage crops. Alfalfa and clover. These soils may support the cultivation of forage crops, providing fodder for livestock in regions with brown steppe soils. 5. Livestock grazing areas. Grazing land. In some areas, brown steppe soils may serve as grazing land for livestock, supporting pastoral activities. 6. Crop rotation practices. Diversification. Farmers may implement crop rotation practices in brown steppe soils to enhance soil fertility and reduce the risk of pests and diseases. 7. Agricultural research. Soil studies. Researchers may conduct studies on brown steppe soils to understand their composition and characteristics, aiding in the development of sustainable agricultural practices. 8. Water management. Efficient irrigation. Given that steppe environments may face water scarcity, efficient irrigation practices become crucial to optimize water use in agriculture. 9. Sustainable agriculture. Conservation practices. Farmers may adopt soil conservation practices, such as contour plowing and cover cropping, to prevent soil erosion in brown steppe soils. 10. Environmental considerations. Biodiversity conservation. Recognizing the importance of steppe ecosystems, efforts may be made to conserve biodiversity in regions with brown steppe soils. Understanding the agricultural potential of brown steppe soils allows for the development of farming strategies that align with the unique characteristics of these soils, promoting sustainable and productive agricultural practices. Brown steppe soils in central Turkey. 1. Grain agriculture. Wheat and barley cultivation. Brown steppe soils in central Turkey are conducive to the cultivation of wheat and barley, contributing significantly to grain agriculture. 2. Livestock farming. Sheep and goat breeding. The central regions with brown steppe soils often support livestock farming, particularly sheep and goat breeding, leveraging the available grazing areas. 3. Agricultural diversification. Crop rotation. Farmers in these areas may implement crop rotation practices to enhance soil fertility and sustain agricultural productivity. 4. Sustainable practices. Soil conservation. Considering the potential for soil erosion in steppe environments, farmers may adopt soil conservation practices to maintain the health of brown steppe soils. 5. Water management. Efficient irrigation. Due to the semi-arid nature of steppe regions, efficient water management becomes crucial for sustaining agricultural activities. 6. Traditional farming wisdom. Adaptation. Local farmers likely apply traditional farming wisdom to adapt their agricultural practices to the unique characteristics of brown steppe soils. 7. Environmental considerations. Biodiversity conservation. Efforts may be made to conserve the natural biodiversity of steppe ecosystems while engaging in agricultural activities. Understanding the agricultural and pastoral activities associated with brown steppe soils in central Turkey provides insights into the region's unique farming practices and the challenges faced in maintaining sustainable agriculture in semi-arid environments. Chestnut-colored steppe soils in Turkey. 1. Geographical distribution. Central and southern regions. Chestnut-colored steppe soils are prevalent in central and southern parts of Turkey, influencing the local agricultural landscape. 2. Agricultural characteristics. Crop diversity. These soils may support a variety of crops, contributing to agricultural diversity in the regions where they are found. 3. Climate adaptation. Semi-arid conditions. Chestnut-colored steppe soils are likely adapted to semi-arid conditions, requiring agricultural practices that consider water conservation and efficient irrigation. 4. Crop rotation practices. Sustainable farming. Farmers in these areas might adopt crop rotation practices to maintain soil fertility and prevent soil degradation. 5. Traditional farming wisdom. Local knowledge. Utilizing traditional farming wisdom, local farmers may have developed practices suited to the specific characteristics of chestnut-colored steppe soils. 6. Livestock integration. Grazing areas. These soils may provide suitable grazing areas, integrating livestock farming with crop cultivation for a balanced agricultural system. 7. Conservation efforts. Soil protection. Considering the vulnerability of steppe soils to erosion, there might be efforts to implement soil conservation techniques to protect against degradation. Understanding the agricultural dynamics associated with chestnut-colored steppe soils sheds light on the region's farming practices, environmental considerations, and the challenges faced by farmers in semi-arid landscapes. In areas where these chestnut-colored steppe soils are found, which are typically seen in the central regions of our country, activities such as grain agriculture, sheep, and goat farming are prevalent. Chernozem, also known as black soils, is a type of soil that is rich in organic matter and minerals. These soils are characterized by their dark color, high fertility, and excellent agricultural potential. Chernozem soils are typically found in the Eurasian steppe region, including parts of Russia, Ukraine, and Kazakhstan. In Turkey, Chernozem soils are not as widespread as in the Eurasian steppe, but they can be found in certain regions with suitable environmental conditions. These soils support various agricultural activities and are known for their ability to sustain crop growth. The dark color of Chernozem is attributed to the accumulation of organic material over time, contributing to the fertility of the soil. In areas characterized by Chernozem soils, which exhibit lush and fertile conditions, cattle breeding is a common agricultural activity. The presence of rich pastures and the overall fertility of Chernozem soils create favorable conditions for grazing, making it conducive to cattle farming in these regions. The abundance of nutrients and organic matter in Chernozem contributes to the quality of the pastures, supporting the health and well-being of the cattle. Designating ore of a soil whose characteristics indicate the dominance of local conditions, such as topography or parent material, over the ordinary effects of climate and vegetation. Intrazonal refers to a category of soils that have characteristics influenced by factors other than the local climate. These soils exhibit features that are not directly related to the current climate of the region where they are found. Instead, they are influenced by factors such as parent material, relief, or the influence of water. Here's some information about intrazonal soils. 1. Vertisol. Characteristics: vertisols are clayey soils known for their high shrink-swell capacity. They undergo significant volume changes with changes in moisture content, forming deep cracks when dry. Formation: they often develop in areas with alternating wet and dry seasons. The shrink-swell behavior is associated with the high clay content, particularly smectite clays. 2. Rendzina. Characteristics: Rendzina soils are characterized by a dark, organic-rich upper horizon overlying a lighter, calcareous horizon. They are often found in limestone regions. Formation: the dark upper horizon results from organic material accumulation, while the calcareous horizon is influenced by the underlying limestone bedrock. 3. Salty soils. Characteristics: salty soils, as the name suggests, contain elevated levels of salts. They may experience salinization due to factors such as irrigation practices, high evaporation rates, or the presence of saline parent material. Formation: salinity can accumulate over time, affecting soil structure and fertility. These intrazonal soils play a crucial role in understanding the complex interactions between geological, topographical, and climatic factors that contribute to soil formation. They highlight the influence of non-climatic factors on soil characteristics. Designating ore of a soil whose characteristics indicate the dominance of local conditions, such as topography or parent material, over the ordinary effects of climate and vegetation. Intrazonal refers to a category of soils that have characteristics influenced by factors other than the local climate. These soils exhibit features that are not directly related to the current climate of the region where they are found. Instead, they are influenced by factors such as parent material, relief, or the influence of water. Here's some information about intrazonal soils. 1. Vertisol. Characteristics: vertisols are clayey soils known for their high shrink-swell capacity. They undergo significant volume changes with changes in moisture content, forming deep cracks when dry. Formation: they often develop in areas with alternating wet and dry seasons. The shrink-swell behavior is associated with the high clay content, particularly smectite clays. 2. Rendzina. Characteristics: Rendzina soils are characterized by a dark, organic-rich upper horizon overlying a lighter, calcareous horizon. They are often found in limestone regions. Formation: the dark upper horizon results from organic material accumulation, while the calcareous horizon is influenced by the underlying limestone bedrock. 3. Salty soils. Characteristics: salty soils, as the name suggests, contain elevated levels of salts. They may experience salinization due to factors such as irrigation practices, high evaporation rates, or the presence of saline parent material. Formation: salinity can accumulate over time, affecting soil structure and fertility. These intrazonal soils play a crucial role in understanding the complex interactions between geological, topographical, and climatic factors that contribute to soil formation. They highlight the influence of non-climatic factors on soil characteristics. The term stone-bearing soil in Anatolia likely refers to the presence of stones or fragments within the vertisols, which can indeed be a characteristic feature. The high clay content in vertisols contributes to their unique properties, including the tendency to form deep cracks when dry and the challenges associated with soil processing. The difficulty in processing vertisols due to their high clay content is a well-known aspect. Farmers and agricultural practitioners often face challenges in tillage and cultivation in these soils, especially during dry periods when the soil can become hard and compacted. Proper soil management practices, such as adding organic matter and employing conservation tillage methods, can help improve the workability of vertisols. If there are specific agricultural or land use concerns related to vertisols in Anatolia, local agricultural extension services or soil science experts can provide tailored advice and solutions based on the unique characteristics of the soil in that region. Rendzina is a soil type characterized by its unique composition and formation. It is commonly associated with limestone-rich areas. Here are some key features of Rendzina soils. 1. Limestone influence. Rendzina soils typically form in regions where limestone or other calcium-rich bedrock is present. The interaction between organic material, rainfall, and carbonate-rich parent material contributes to the development of Rendzina. 2. Calcium carbonate content. These soils are often rich in calcium carbonate, which can lead to the formation of a distinctive soil horizon known as a calcic horizon or rendzic horizon. 3. Dark surface horizon. Rendzina soils usually have a dark, fertile surface horizon, topsoil, due to the accumulation of organic matter from decaying plant material. 4. Calcareous horizon. Below the dark topsoil, there is often a layer enriched with calcium carbonate. This layer may exhibit characteristics associated with calcareous material. 5. Productivity. Rendzina soils are generally fertile and can be suitable for agriculture. The presence of organic matter in the topsoil contributes to their fertility. 6. Crops. Depending on local climate and land management practices, Rendzina soils may support a variety of crops. However, the suitability for specific crops may vary, and soil management practices need to consider the calcium carbonate content. It's important to note that the characteristics of Rendzina soils can vary depending on specific local conditions, including climate, vegetation, and land use. If you have specific questions about Rendzina soils in a particular region or for particular agricultural purposes, consulting with local soil experts or agricultural extension services would provide more tailored information. Rendzina's occurrence in various regions, including Marmara, Mediterranean, Aegean, Central, and Eastern Anatolia, aligns with the general understanding of its association with limestone-rich areas. Salty soils, as the name suggests, are soils that have a high concentration of salts. These soils can be problematic for agriculture because excessive salt content can be detrimental to plant growth. Salty soils are often found in arid and semi-arid regions where there is limited rainfall and poor drainage. In Turkey, the presence of salty soils may vary across different regions, and they are more likely to occur in areas with arid or semi-arid climates. Salinity in soils can result from factors such as the accumulation of salts through evaporation, irrigation practices, or the natural composition of the soil and underlying rocks. Salty soils, also known as saline soils, are formed through a process called salinization. Salinization occurs when the concentration of soluble salts in the soil increases to levels that are harmful to plants. Here are some common causes of the formation of salty soils. 1. Natural processes. In arid and semi-arid regions, where evaporation rates exceed precipitation, salts in the soil can become concentrated. When water evaporates from the soil surface, it leaves the salts behind, leading to an increase in salinity. 2. Irrigation practices. In agricultural areas, improper irrigation practices can contribute to salinization. If the water used for irrigation contains dissolved salts, and there's insufficient drainage to carry away the excess salts, they can accumulate in the soil over time. 3. Groundwater movement. Salty soils can also result from the movement of saline groundwater into the root zone of plants. This is common in areas where the groundwater itself is saline. 4. Geological factors. The underlying geological formations can influence soil salinity. Certain rocks and minerals naturally contain salts, and weathering of these materials can release salts into the soil. 5. Human activities. Human activities, such as deforestation and urbanization, can alter the natural balance of water and salt cycles in the soil, leading to increased salinity. In regions where salty soils are prevalent, it's important to implement proper soil management practices, including drainage systems and careful irrigation, to mitigate the impact of salinization on agricultural productivity. Salty soils, or saline soils, are indeed found in regions around Tuz Lake and in the Konya Plain in Turkey. Tuz Lake, located in the central part of the country, is known for its high salinity, and the surrounding areas may experience salinization in the soil due to the lake's influence and other contributing factors. In agricultural contexts, dealing with saline soils requires careful management practices, including proper irrigation techniques, drainage systems, and, in some cases, the use of soil amendments to improve soil structure and fertility. These measures help minimize the adverse effects of salinity on crop growth and productivity. The term azonal in soil science refers to soils that do not fit well into the typical zonal classification based on climate and vegetation. Azonal soils are those whose development is not primarily controlled by the local climate, and they often exhibit characteristics that are not directly related to the typical soil forming factors. Scientifically, azonal soils can include various soil types that deviate from the typical zonal patterns. They are influenced by factors such as topography, parent material, or human activities more than by the prevailing climate. Here are some examples of azonal soils. 1. Alluvial soils. These soils are often found in river valleys and floodplains. They are formed by the deposition of sediments carried by rivers and streams. 2. Colluvial soils. These soils result from the accumulation of material, such as rock fragments and soil, at the base of slopes due to gravity. 3. Regisol, a type of soil that lacks horizon development, often found in recently deposited materials like sand dunes or volcanic ash. These soil types are more influenced by factors other than climate, making them distinct from the zonal soils that are directly tied to the local climate and vegetation. Understanding azonal soils is crucial for various applications, including agriculture, land use planning, and environmental management. Alluvial soils are soils that are deposited by rivers and other running water bodies. They are formed by the transportation and deposition of sediments carried by flowing water. These soils are typically found in river valleys, floodplains, and delta areas. Here are some key characteristics and features of alluvial soils. 1. Formation. Alluvial soils are formed through the continuous deposition of fine sediments like silt, clay, and sand by moving water. This deposition occurs during periods of flooding when rivers overflow their banks and deposit sediment on the adjacent land. 2. Composition. The composition of alluvial soils varies, but they are generally a mixture of sand, silt, clay, and organic matter. The specific composition depends on the geology of the upstream areas from which the sediments are eroded. 3. Fertility. Alluvial soils are often fertile due to the deposition of nutrient-rich sediments. The frequent flooding of rivers brings fresh minerals and organic matter to the soil, contributing to its fertility. 4. Texture. The texture of alluvial soils can vary widely, ranging from sandy to loamy to clayey, depending on the size of the sediments deposited. 5. Water retention. Alluvial soils generally have good water retention capacity, making them suitable for agriculture. However, they may also be prone to waterlogging in certain conditions. 6. Use in agriculture. Due to their fertility, alluvial soils are extensively used for agriculture. They support the growth of a variety of crops, and many of the world's major agricultural regions are located in alluvial plains. 7. Natural deposition patterns. Alluvial soils exhibit distinct layers or horizons representing different periods of deposition. These layers can provide insights into the geological history of the region. 8. Vulnerability to erosion. While alluvial soils are formed by erosion and deposition, they are also vulnerable to erosion, especially if vegetation cover is removed or disturbed. Overall, alluvial soils play a crucial role in supporting agricultural activities and are often associated with the fertile plains of major rivers around the world. In Turkey, alluvial soils are commonly found in various regions, particularly in areas with river valleys, floodplains, and delta regions. Some of the main areas where alluvial soils are seen in Turkey include: 1. Çukurova, Cilicia, Plain, located in the southern part of Turkey. Çukurova is a large plain formed by the alluvial deposits of the Seyhan and Ceyhan rivers. It is known for its fertile soils and is a major agricultural region producing a variety of crops. 2. Çırmak Delta. The Çırmak River, one of the major rivers in Turkey, forms a delta where it meets the Black Sea. The delta area is characterized by alluvial soils and is important for agriculture. 3. Menderes Delta. The Menderes River, flowing into the Aegean Sea, forms a delta with alluvial soils. This region is part of the larger Aegean region, known for its agricultural productivity. 4. Gediz Delta. The Gediz River, also flowing into the Aegean Sea, contributes to the formation of alluvial soils in the Gettys Delta. It is another area with agricultural significance. 5. Sakarya River Basin. The Sakarya River and its basin, located in the northwest of Turkey, are associated with alluvial soils. This region supports agricultural activities. 6. Frat, Euphrates, and Dikil, Tigris, river basins. The plains and valleys along the Frat and Dikil rivers in southeastern Turkey have alluvial soils that support agriculture. 7. Sora Valley. The Sora River Basin in northeastern Turkey features alluvial soils, contributing to the agricultural landscape of the region. These are just a few examples, and there are many other river valleys, plains, and deltas throughout Turkey where alluvial soils play a crucial role in supporting agricultural activities. The central parts of Turkey, including plains such as Erzurum, Erzincan, Muz, Erbaa, Niksar, and Konya, are indeed characterized by extensive areas of alluvial soils. These plains, formed by the deposition of sediment carried by rivers over time, are highly fertile and conducive to various agricultural activities. The composition and fertility of alluvial soils make them valuable for cultivation, and they play a vital role in supporting the agricultural economy of these regions. Thank you for providing specific examples to enhance the understanding of alluvial soil distribution in Turkey. Alluvial soils in Turkey are found in various regions, particularly in plains and river valleys where sediments have been deposited by rivers over time. Some notable areas with significant occurrences of alluvial soils include 1. Konya Plain. The Konya Plain, located in central Turkey, is one of the major regions with extensive alluvial soils. The alluvial deposits in this area contribute to the fertility of the soil, supporting diverse agricultural activities. 2. Erzurum. The province of Erzurum, situated in eastern Turkey, has plains and valleys where alluvial soils are prevalent. These soils play a crucial role in the agricultural productivity of the region. 3. Erzincan. Similar to Erzurum, the province of Erzincan, located in Eastern Anatolia, features plains and valleys with significant deposits of alluvial soils. 4. Muz. The province of Muz, also in eastern Turkey, has plains where alluvial soils are found. These soils contribute to the fertility of the agricultural land in the region. 5. Erbaa and Niksar. These are towns located in the province of Tokat in northern Turkey. The areas around Erbaa and Niksar are known for the presence of alluvial soils, supporting agriculture in the region. These regions benefit from the fertility of alluvial soils, making them suitable for various crops. The deposition of sediments by rivers over time creates a fertile environment for agriculture, and farmers in these areas take advantage of these rich soils for cultivation. Alluvial soils, characterized by their ease of cultivation, richness in minerals, and organic content, boast high agricultural productivity. As a result, regions with abundant alluvial soils play a pivotal role in the agriculture of our country. The fertility of these soils, attributed to the deposition of minerals and organic materials by rivers over time, makes them conducive to achieving high yields in cultivation. Farmers in these areas leverage the advantages of these fertile soils, contributing to the agricultural prosperity of Turkey. Colluvial soils in Turkey are typically found in mountainous or hilly regions where the accumulation of rock fragments, debris, and soil material occurs due to gravitational forces. These soils are influenced by the movement of material downslope, often facilitated by factors such as erosion, weathering, and gravitational pull. Colluvial soils are characterized by their mixed composition, incorporating a variety of materials from the surrounding terrain. Their fertility and suitability for cultivation can vary based on the specific geological and climatic conditions of each region. In Turkey, areas with colluvial soils may experience unique agricultural challenges and opportunities depending on the local topography and climate. Farmers in these regions adapt their cultivation practices to the characteristics of colluvial soils, contributing to the diverse agricultural landscape of the country. Regisols, also known as desert soils, are found in arid and semi-arid regions with limited vegetation cover. These soils are characterized by a lack of horizon development, as factors like leaching and organic matter accumulation are limited in such dry environments. In Turkey, regisols may be present in certain areas with arid or semi-arid climates, such as parts of central and southeastern Anatolia. These soils are often associated with regions where water availability is low, and the climate is more prone to aridity. The agricultural potential of Grisoils is limited due to their low fertility and lack of well-defined soil horizons. However, local adaptation and sustainable land management practices can be employed to make productive use of these soils, especially in regions where water conservation and soil improvement measures are implemented.